into the Google Classroom and looking under today's date, the 9th, opening up this Google Doc. It looks different on your end, but I made you a copy. It already has your name on it. All right. Going into that document, you're just going to follow along with me. First thing, let's go ahead and let's just type our name in here. So I'm Mr. Held. And today's date is 12/07/20. No, 12/07, 12/09. All right. So this comes right from our textbook in chapter 5 under friction. And here's the image they give. And so you could imagine someone on a slope, a skier on a slope. And the skier on the slope, they are sliding down the slope at a constant velocity. They're not accelerating. They're moving. And they basically, if you look at the free body diagram here on the right, what's happening is the sine component of the weight, which is parallel going down the slope, that component is equal to the frictional force. And the object is moving. It's in motion, but it's not accelerating. All right. So remember, if you have an unbalanced force on you, Newton's second law says that you will accelerate. You can move, however, without having an unbalanced force. And so that's the goal of what we're going to do. So again, I'm trying to explain to you what this is saying. So an object will slide down an inclined plane at a constant velocity if the net force on the object is 0. We can use this fact to measure the coefficient of friction between two objects. And one of the things I may have said yesterday that might have been misleading is when I said that an object's coefficient of friction is how rough it is. It's more than that. It's actually, and what we're going to see that today in the lab, the coefficient of friction is not for one object in particular. It's for two objects and the way they interact with one another. And you'll see that we'll have a coin and we'll be able to find a different coefficient of friction between the coin in the books. It's a relationship between two objects. Okay? All right. So the kinetic, all right, as shown in this figure, which is the picture above, the kinetic friction on a slope is the F sub k, or the force of kinetic friction, is equal to mu sub k. That would be the coefficient of kinetic friction, all right, times m, which is the mass, times g, which is gravity, times the cosine of theta. All right. That's because that's this right here. I don't know. Can we see my cursor? No, we can't. That would be equal to the normal force, right? Yes, the component that is equal and opposite of the normal force. All right. So these forces act in opposite directions, and they have an equal magnitude. The acceleration is 0, so we can write these forces out. Okay, so there's two forces here. The force of kinetic friction and the force of the component that is going down, the weight component that is going parallel to the slope. Okay? And so basically what we're saying is they should be equal to one another. And so here's just some math that the book is showing you, that if we substitute in the values for these two things and set them equal to each other, and we solve for the coefficient of kinetic friction, we get this math right here. And it equals, basically, mass cancels out, gravity cancels out, and we get the sine of theta over the cosine of theta, which is equal to the tangent of theta. So it's actually kind of cool. Once we find this point where the object is able to slide down at a constant velocity, and you should be able to see this when we do it. All we have to do is measure the angle, and we can calculate the coefficient of kinetic friction. All right, and that's what we're going to be doing today. So this is going to give us some ideas on how we're going to do this assignment. All right, let's get started. So what I've done for you is I've at least put in the different categories of things that I want you to fill out. And I'm going to show you how to do this. We're going to do this right together. I'm going to type, you're going to type. You can copy exactly what I'm saying. You can do it in your own words. That's fine. Either way. So the way I always do experiments is first I state the problem. And I like to write my problem as a question. Okay? So what we're actually doing in today's lab is we are finding the coefficient of friction for a ramp and an object sliding down. Okay? So I'm going to write the question, what is the coefficient of kinetic friction of a coin sliding down a ramp? That's simple. Okay? So you go ahead and you type that in on your worksheet. All right? And my bad. It should be a question mark. It's a question. Duh. There we go. All right. Hopefully you're able to do that. I know some of you might not type as fast as me. I don't type that fast, but I might type faster than you do. So we're going to write a hypothesis. How should a hypothesis should be written? Go ahead and type in chat or unmute. And let me just see if you guys know this, or at least have heard it the way I do it. How should it be written? Anybody know?
Isn't it like if blank happens, then blank will happen because?
Yes, perfect. Yes, if, then, because. If, then, because. All right. Perfect. So if, and let's come up with an idea. So the if is, that's kind of, that's the prediction. So, or that's what we have. So if, well, we're going to turn this into an experiment, and I have different ramps. Okay? So I'm going to say this. This is my idea. If the ramp is smooth, then the coefficient, and it wants to do that, so I'll just hit tab and it'll fill in, autofill. If the ramp is smooth, then the coefficient of friction will be less. So if we have the smooth ramp, so if the ramp is smooth, then the coefficient of friction will be less. So there's my prediction. And then here's my why. All right. Because rough surfaces have a higher coefficient of friction. So kind of basic. I suppose that's good enough. If you have a better idea, go for it. All right? Sounds good to me. So if, then, because. Prediction. All right. Now I'm going to do materials. And I do this sort of thing all the time, so I want to show you how to do it because it saves time. Why not? I'm going to go right into today's assignment. You have access to this too, so let me show you something. I have to press edit to do this. You don't. So I'm going to click, just highlight this, and I'm just going to highlight, and I'm boom, copy. I'm going to go back here into my worksheet, and then I'm going to paste it. And I'm also going to show you, we're going to add in some bullets. So if you don't know this, command, or depending on you using a Mac or a PC, it's Control C is copy and Control V is paste. Or if you're using a Mac, it's Command C for copy and Command V for paste. Hope you already know that. Saves a lot of time to be able to copy and paste things quickly. You can also highlight something like this and two-finger click it, and then one of the things will be copied. You can bring up a menu that way too. What I'm going to do here is I'm going to click on Format, and I'm going to bring in a bulleted list. Okay? And I'm going to select the first option. Okay? And just for looks. So I'm just trying to teach you just a little bit of how to edit a Word document. So I'm just going to put bullets in there. It just makes it look nice because it's a list. And to get it started, I have to delete and then press enter like I'm doing to get it to be bulleted. How am I doing, guys? Am I going way too fast? Are you keeping up? Okay, so far so good. Christina's good. Victoria's good. George is good. All right, we'll keep going. All right. All right. So procedure, instead of doing a bulleted list, let's do a numbered list this time. All right. So same idea. We go up to Format. We click on Format and bullets and numbering. And this time I'm going to do a numbered list. Okay. What should our first step be?
Gather the material.
Sure. Sounds great. A lot of times I see students write that. That's cool. Let's do that. Gather the materials. Cool. All right. I had a feeling that I don't know how I knew that was what we were going to say, but yeah, perfect. I love it. Read my mind. Yeah, we're going to gather the materials. So I've done that. I've got my materials right here. Okay. All right. All right. All right. And if you're like, well, I don't know what we're doing, well, let's go back up a little bit just to remind you what it's saying. And it says, put a coin on the book and tilt it until the coin slides at a constant velocity down the book. Okay. This is how I roll. Sounds good. Number one. All right, now I'm going to turn on my camera and kind of show you what that looks like, just so that and you can practice it too. All right. I just had it off because I thought it might be kind of distracting to see my arms and such while I was typing. So here I have my book, and I have my coin. Okay, hopefully you can see this. And just to point out to you, I don't know how you view this class. I have an extension it's called Grid View. But if you click pin on the picture of what I'm doing right now, it should, and I'm going to do that in my video here, it should make it, I turn off my Grid View and I pin this picture, and it should make this full screen so you can see it better. And later you'll be able to see this video if you don't know how to do that. I'll post this video and you'll be able to see it because it's looking really good on my end. All right, so now I have this coin. Yeah, really good. I have this coin on the book. And when I start to tilt the book, it doesn't immediately start to slide down. And so one of the things it talks about is you might have to, I just tapped it once to get it moving. And that tap gave it a little extra force to overcome the coefficient of static friction and start sliding down. Now, I'll show you again, it's not sliding. Now, if I do it, I'm just going to go like at a really sharp angle. And that was really hard to see. You can tell that it's accelerating. Like, that was way too steep. So you're going to have to practice your coin ramp system a little bit. And just kind of, I'm tapping it with my finger. I don't know if you can see. Yeah, we can see that. I'm tapping it. And what I'm doing is I'm lifting it. And there we go. There's my angle. And you can practice that a few times until you get it right. Yep, it should not just start sliding automatically. You should be tapping it. See, and then I'm increasing my angle a little bit. And there it goes. It starts sliding. Okay? All right. I don't know how well you could see that. So that's the procedure we're using. I'm going back. I'm back to my lab write-up. and I'm going to put that as step 3. And I'm just going to fix some of the stuff like capitalize that. Tap the book lightly to get the coin to move as you slowly increase the angle of the book. We'll just, and I'll put in parentheses ramp. All right. And then step 4 will then, when the coin slides, use your protractor to measure the angle. And then repeat with all 3 ramp types. I think that's good so far. That's a good procedure. I'm ready to start collecting data. This is running really good. I think this is good. I hope you're following along with me. I'll slow down a little and again let you type in those steps. All right, so I've got 5 steps now. All right. So now under data, I want to insert my own. I want to insert a chart to collect the data. So I go to insert and table, and that has this grid. Now I have three different types of books. So I want 4 columns. And I have 2 different types of items. So I would want at least 3 rows. I'm actually going to need more than that, but that's okay. I'm going to just select that. So I did a 4x3 grid to start with. And I'm going to show you, like, if you're like, oh, what if I want to measure something else? I'll show you how to add another grid in too. It's going to be more than this. All right. But there that is. I hope you can do that. I'm going to click Command Z, which is undo. And I'm going to do that again so that we can see it. All right, so I'll say insert table. This isn't the only way to do it, but this is one way. And I'm just going to pick a 4x3 to start off with. And it automatically makes it for me in my data table. All right. And this column here is going to be my coin, and this will be my candy. All right. And what we're going to do is we're going to put theta here. So I talked about this yesterday. I'm going to show you this too. This is great. So I'm going to use, I don't normally do it this way. I'm just showing you that this is one way to do it. Insert special characters. This is where you would find some of these things like theta and whatnot. And these are arrows. If I go to math, I think. I haven't done this in so long. I normally don't do this, but as you can see, because it's kind of clunky, it just takes so long. But all of your stuff like delta and a bunch of these maths, the summation sign, all these math things are right here. I'm not seeing theta though. So I'm going to go to another type of, and maybe it'd be under Greek or Latin, or I'm pretty sure theta is Greek.
If you search it in the toolbar, like the right, if you just look up theta, it should come.
Awesome. Thank you, Christina. That's a great way to do it. I'll just type in theta, like Christina said, and
How
bam.
did you get to the insert special characters? I didn't see that.
Yeah, sure. it's just under insert. So you got it. You said it. So insert, and then here it is, special character. And then yes, that's awesome. I don't even know what that would be under, but that's the best way to do it. Theta. I just typed that in, and look, they got a couple different thetas. I don't know. You pick which one you like. I like that one. That's cool. All right. And then when I double click it, I think it already inserted it. Yeah, a bunch of times, right? So just for all purposes, from here on out, I wouldn't mess. I would never do that again. I would just copy and paste that theta from here on out. So I'm going to put that theta there, okay? And in this, and I did that so fast. I clicked here and centered it. It just makes it look good, okay? And then on this column, what we're going to use is, this is going to be my mu k. And here's a trick. I've already done this in this. It's right here. So let's just copy it from here instead of looking up mu. I mean, you can the same way we just did, but it's already on here. We could have actually copied and pasted this theta as well. I just wanted to show you where special characters are if you ever use it in the future. I usually just look for it and copy and paste it. And if I can't find it, I find it easier just to type in a Google search. But it's really personal preference. They're equally fast, I suppose. Especially when you just type it in. I would imagine if I type in insert special character and type in mu, I should just get mu, huh? Anybody do that? Mu? Yeah, there it is. Boom. So, you know.
Wait, how did you make the bar again? The bar graph?
What, this chart?
Yeah, the chart, my bad.
Yeah, you're right. Table, actually. Insert table, and then I went 4, 3, like that. Right? Okay. So that's going to be mu k. I think that's all we need right now. So maybe we don't have to insert one. Okay. So no. Scratch that. Theta smooth book. And theta medium book. Why not? And I'm just copying and pasting in here. Theta rough book. And in parentheses, I'm going to put paper towel. This is the one that I put taped paper towel to. Okay? All right. And yeah, that's not how I want to do this. All right. I want to put that mu k. I guess I'm going to do it right here. I guess that makes the most sense. You'll see what I mean. All right. So now I'm going to actually collect some data here and put it in. All right. And so here's my book. I already showed this before. This is my smooth book. It's really smooth. All right, and you can do this too on your end if you have all your materials. So I'm going to start lifting up the book so that, hang on, let me change my view over here. Perfect. All right, so I'm going to start slowly lifting the book and creating a bigger angle and see how that's just absolutely perfect. That is exactly it. Then I come in with my protractor and I measure the angle. Okay? Kind of hard for me to show it there. I'm going to do it again. So I tap the book and it slides. And see that? It was not accelerating. It was at a constant velocity, nice and slow. If I'm too high like this, it'll be super fast. Like that was close, but kind of fast. It should go nice and slow. Just like that. And then I set this up right here, and I measure, and I'd say my angle, to me, looks like 12 degrees. So now I'm going to go into, and I'm going to type in 12, and I want degrees. I don't have that, so insert special character, and I just type in degree. Degree.
How do you get your poetry? Like, how do you like check your degrees?
Okay. Sure. So let me go back. And so basically, my protractor's flat on the table, and I put the 0 mark, so that would be like right at the center. Mine has like that circle there, and I want that kind of where I'm just kind of estimating, because my book has some thickness. So that's why I've chosen such a thin book. Let me try to explain that. Let me grab a thicker book so you can see what would be wrong with a thicker book. Alright, so like this book is really thick. So when I have it at an angle, it's kind of hard to anticipate where it's touching to. So you'd almost want to put a piece of paper on there to like figure out where it's hitting the table. I can't. Can I show this angle here? If you, I don't know if you can see what I mean. Because of the thickness of the book, it's kind of hard to tell where it meets the table. That's why the thinner the book, the better. Yeah, and you want to center your protractor like that. And then it's hard for you to see on that angle, so let me bring it over here. So, and then you're reading it. And like, for instance, my protractor, it depends on if you're measuring a acute angle or obtuse. So this would be, the 10 is acute and the 170 is obtuse. And so you kind of, this is going to be an acute angle. I hope you know what I'm talking about. That's geometry for you. So mine looked like it was, so you're just kind of measuring it there. It's really hard for me to show that. I'd have to move, let me move my camera down. Yeah, nice. So, like so. And really it would be at the top of the book. So the top would be what you're looking for. Okay. So I got 12 degrees with that book. Now I'm going to bring in my green book. Okay. And my green book's a little bit thicker, as you can see, but it has this kind of rough surface. It's an old, really old book. And it just feels like it's friction. The coefficient of friction will be higher. Okay, so same thing. And that feels like a pretty good angle. Kind of hard to do it myself here and hold it there. But I'm going to set up my protractor. And hard for me to read it. Looks like 14 degrees to me. Didn't look too different. So instead of looking for the degree sign, I'm just going to copy my 12 degrees. And I'm just going to change that to 14. And now I'm going to move over to my rough book, my paper towel. All right. And so, really, this is a smooth book. It's a Where's Waldo book. It's smooth, but I taped paper towel to it to make it rougher. Right? And I'm going to move this back up. I just feel like it was better right here. Okay.
Mr. Hill,
Yep.
what is that symbol that's right underneath the coin?
What's what symbol?
Yeah, the right.
Let me go back to that. I just moved it. This symbol after the 14?
No, the symbol underneath coin.
Oh, that's mu k, sub k.
Okay.
Yep. Which is the coefficient of kinetic friction. That's what we're trying to measure. All right? Or at least calculate. We're measuring the degree angle, and then we're going to, all we have to do is take the tangent of 12, and we'll get our coefficient of kinetic friction, the tangent of, and so on and so forth. Multiply it. No, just the tangent of. All right. So I'm going to measure this angle. So same thing. I drop my protractor. So here's my protractor, and I'm going to lift this. And you can see the paper towel is much rougher. So it takes a couple times to get it nice and slow. I'm just tapping it and raising it a little bit and trying to get it to slide. There it is. Okay. Kind of. On my end, it looks like 16 degrees. Let me try that again. Because it feels like it's so much higher than that compared to the other two. Yeah, I'm going to call mine 18 degrees. All right. And now what I'm going to do and you can use a calculator, or I didn't put this in our material list because, you know, I mean, calculator, we use that every day. We're using computers right now just to be here. So I'm going to use Desmos. That's what you guys use, I think. So if you don't have a calculator in front of you or whatever, you can just open up Desmos. And so if your values are different than mine, and so we'll go into Desmos, and I'm going to just type in the tangent of, I need to know what the tangent of 12, 14, and 16 are. And that'll give me my three coefficients of kinetic friction. So 0.21 for 12. So going back here, I'm just going to type in 0.21. I'll just do 2 sig figs. And
Sorry, what did you do? You froze really hard for me.
so I'm in Desmos, and I'm just finding the tangent of theta. So tangent of 14 for my second one is 0.25. So I'm just going back and forth between my calculator and my data chart, and 0.25. And so, and then finally 18 would be the last one. So I just go over here to Desmos and I type in the tangent of 18, and that gives me 0.32. So now I go back in and I'm going to put in that data, 0.32. All right. Cool. All right. But that's not it. Now I can work on, instead of my coin, I'm going to do the same thing. I'm just going to do it with my candy. Okay? And so, first of all, since we've collected the data here, I'd like you to see that, again, I didn't change the coin. It's the same coin. So the coefficient of friction is not for the coin, it's for the relationship between the coin and the ramp that it's on. And it's between the two materials that are in contact with each other. That's what the coefficient of friction is. Not necessarily for just the coin, but the coin and the rough book, or the coin and the medium book. All right? And so now I have a candy that I'm going to use, and this could be a Tootsie Roll, or this is a Werther's Original, which is, it's not a hard one, it's the soft kind, the chewable kind, but it's kind of like a Tootsie Roll. It's not perfectly cylindrical, and that makes it perfect for what I'm going to show you. And so, first, without measuring, I just want to show you some things. So, unlike the coin really didn't matter which way I turn it because it's just a circular object. This has an axis that if I point it downhill, it's going to react differently than it can react differently than when I put it down the hill this way, but not in this situation. So let me show you what I mean. So when I start raising where there it goes. All right, I'll show you that again. It's going to slide down, not roll, by the way. Let me back up a little with my. I can't see the top. I'll change my camera angle. It's not as focused though. All right, I think you can kind of see it, and so then I'm tapping it. Alright, so right there. And I'm going to take my protractor here. And I'm right at 20. So going to my new candy one, this is 20 degrees. 20. And if you wanted to, you could highlight all of this and center that. And I'm going to do that here too. It's not completely necessary, but see how nice that looks? It looks nicer. Okay. All right, now I'm going to bring in my medium book. And I'm seeing that we have 3 minutes left. So I'm not going to take any more data. I wanted to show you this. This is what's really cool about this. And we'll talk about it more tomorrow. If I use the rough surface, and it'll slide, and I go, and I have the axis like this, it'll slide down. But if I turn it this way, it won't slide. Look, this was working yesterday. Yeah, there it goes. So if I have it set up this way, it rolls. The angle, and actually when it starts rolling, this is what I want to do tomorrow. When it starts rolling, it rolls sooner than it will slide. And so the kinetic, it shows that the coefficient of kinetic rolling friction for this candy is lower than sliding friction. Just kind of showing you the difference between the two. As you can see, it's sliding, but if I get it just right, I can't get it to roll today. Why is it not rolling? There it goes. Yeah, at a very low angle, it sometimes will roll like that. And you could kind of do that with a marker. I have a marker here, and if I have the marker, it's not going to roll end to end, so it's going to slide down. See? But if I have it this way, I don't have to give it much angle at all, and it's going to start rolling. Right? Okay, so hopefully that was fun. We'll continue this lab and finish it up tomorrow. Should be able to get it done, write our conclusion, and submit it in the Google Classroom tomorrow. We'll see you tomorrow.